50-ton Trane chiller. You'll notice that all the schematics are on the inside of the door, are all legible. This unit is wired 480 volt coming in. It has 4 compressors and a grand total of 6 fans. We're going to fire this unit up here in a minute and show you. They had this unit running an air handler in a building as well as a process for a factory making plastic profile. So there's one right over here. There's a low voltage set of wires which I've marked building. These right here could be put to an air handler if you want. If not, you can use 100% of your capacity for whatever else, you know, for your process water. The blue one right over here is marked flow switch. This is your external flow switch that you'll end up hooking up in order to make sure that the unit has water moving through it. And last but not least, it does require a 110 input for the actual control circuit. It doesn't have an internal transformer. So the black and the white wire are your 110 volt input. Okay? I'm going to give you a quick overview around the outside of this unit, and then we're going to turn it on. We hooked 3 wires to a temporary pump in order to put water through the heat exchanger. I marked the in as in and the out as the out over here. Also, you'll also notice that there is some markings right over here that show you based on the type of the chiller where the water should be going in and out. But we did mark them already in and out, and we have a 10 horsepower pump running on it. Here you can see the compressors. And the condenser coil. The guards for the where the compressors are, we just took them off just to show you the compressors with the unit running. Once the unit is plugged in, the 110 and the 480 volt is turned on, you'll notice that your annunciator panel will start to give you readings. It takes a while for this unit to warm up. Remember, the compressors themselves actually have to physically warm up and get up to temperature before it'll actually allow them to fire. This unit is designed so that it runs 10, 20, 30, it'll run 1 compressor, then 2 compressors, then 3 compressors, then 4 compressors as needed. It only runs the compressors as needed. If it doesn't keep up with itself, it'll fire more compressors to keep the unit running more. So it only pulls in as much as it needs in order to maintain what it has to for its capacity, so that she runs and doesn't waste all the electricity to run all the compressors. She'll pull them in as she needs them. Here we go, the unit just turned on, and we'll show you some of the functions we have over here. The E is incoming temperature. It just pulled in a second compressor. I don't know if you heard that or not. She wasn't quite happy with cooling down quick enough. So D is your set point. D is the set point. E is the temperature coming in. This is the temperature of the water coming in. F is the temperature leaving the chiller. So we're sending water out at 71 degrees. Our set point is 55. Our incoming water is 84. So now, as you can see, as we're putting cold water into the holding tank, it's dropping slowly. And our outgoing temperature is now 70. Okay? So we're just going to keep an eye on that outgoing temperature, and you'll see her slowly starting to drop. Okay? So once again, we scroll through, and D is our set point. You set our set point right here. We have the chilled water set point. Very simply turning this will bring it up or down, your set point for your temperature. Currently I have it set at 55 degrees Fahrenheit. The water entering the chiller is 81. The temperature leaving the chiller is 69. Now it's 68. You'll notice it keeps dropping the temperature. What I have the water looping through the heat exchanger on the unit up into a holding tank. coming out of here and going up over into a large holding tank over here. And you'll see she just dropped to 67 degrees. And she just dropped to 66 degrees. Again, our entering temperature is our E number. D is our set point. E is our entering. We're now down to 76 degrees entering. And our temperature leaving the chiller is 66. So it's coming out of the holding tank and going into the chiller at 76 degrees, and it's leaving the chiller and going back to the holding tank at 66 degrees. You're getting a 10-degree drop going across the chiller. Now it's 65. Here you can see your compressors running quite well. Nobody making any funny noises. Everything seems to be just fine. And now our incoming temperature is 64 degrees. 63 now, it dropped another degree. Water continues to drop. We are now down to 59 degrees exiting temperature. Of course, our F is the leaving temperature. 55 is our set point. 67, 66 is now our incoming. This is now the temperature of the water coming from the aluminum holding tank. Entering the chiller now is 66. And our water leaving the chiller is now 58. So we're doing very well over here. She's coming way down in temperature extremely fast. But it is a big chiller, 55 tons. Notice that we have all 6 fans turning. All 6 fans are blowing and pulling air through the heat exchangers. They're all running. Every one of them runs well. He's pulling well. Here's our water returning to our holding tank. The chiller as it is very quiet. You'll notice now that the leaving temperature is now 56 degrees. So in a few minutes we'll start to hear the chillers. The compressors will actually cut out because it'll say, okay, we've reached our set point, which is 55 degrees. This unit is Unit 1. We have 2 of these units. This is Unit 1. This is an R22 unit, and she has now reached 55, so she will now extinguish her chillers, her compressors. Okay, so this is an R22 unit. You'll notice everything on the door is complete, very, very legible. No problem reading any of the wiring. Nobody inside has really been changed. It's pretty much the way it belongs. Unit checks good, drops in temperature fast. If you have any questions, give me a call. Thank you very much for showing interest. Includes the taping of chiller Unit 1, 50-ton Trane, running unit. Watching it run right now.